Hello there and welcome back to the engineering experience. In today's video, I'm going through exercise 1.3 from the Art of Electronics, and this exercise focuses on series and parallel resistors. Exercise 1.3 says, prove the formulas for series and parallel resistors. So firstly, let's look at series resistors. Series resistors are when the resistors are connected end to end, as you can see on the screen now. Notice we know the equivalent resistance of resistors connected in this way is basically the summation of all the resistors. So in this case, it would be R1 plus R2 all the way up to Rn, and that would be your total resistance. Now to get to that equation, first of all, you can look at Kirchhoff's voltage law, which basically says that the summation of these voltages is equal to the voltage that's present on the power supply. Denote this as V1 in this case. Then the voltage across R1 plus the voltage across R2 all the way up to Rn is equal to voltage across V1. And we can write this down as V1 equals VR1 plus VR2 up to Vrn. Now Kirchhoff's current law says that the current in the loop is going to be the same. So as all the resistors are connected in series, the current through them is all going to be the same. So let's denote that with I. So I through V1 is equal to I through R1, and that's also equal to I through R2 and any number of combination of resistors that you have in this chain. Ohm's law describes the relationship between voltage, current and resistance, and you can see the triangle that helps you work out which is which and the relationship to it. So voltage is equal to the current times the resistance. Now, obviously, in this case over here, we have the voltage equation and we have the current through the resistors. So what we are doing here is replacing VR1, VR2, all the way up to Vrn with this equation over here. So we know the current through them, which is I, is basically equal in all cases. And then we have separate resistors, so R1 plus R2, all the way up to Rn. So V1, we know the value from here. Now if you simplify that a little bit and bring out the I by itself, we end up with V1 equals I, and in brackets we've got R1 plus R2 plus all the way up to Rn. And you can see now that the equation is coming together for what we expect with series resistors. Now looking at the voltage triangle again, you can see voltage divided by current is equal to the resistance. Taking this I onto the other side, you get voltage divided by current. So that gives you the equivalent resistance of this circuit. So the equivalent resistance is equal to V1 divided by current, which is the same through all the resistors, is equal to R1 plus R2 plus all the way up to Rn. So this is the proof for series resistor equation and basically how you get to it. So obviously you need to use Kirchhoff's current law, Kirchhoff's voltage law and Ohm's law to get to it. Now let's move on to parallel resistor equation. On the screen now you can see resistors connected in parallel. And the equation for this is 1 over total resistance is equal to 1 over R1 plus 1 over R2 all the way up to 1 over R1. To derive that equation, you can start off with the Kirchhoff's current law, which basically tells you that the current that's going through this path over here is equal to the current that's going down R1 plus the current that's going down R2 up to any number of parallel resistors that you have in this combination. Now introducing Ohm's law into this equation, we can rewrite I of R1 as V2, as the voltage across all of these resistors is going to be the same due to Kirchhoff's voltage law. So that's V2 divided by R1 is equal to the current through R1 plus V2 divided by R2 plus all the way up to whatever resistor you have here. Now this should say a plus on this side here. If you rearrange this equation, you can bring out V2 by itself because obviously it's a common factor there. So bringing the V2 out by itself, you get the current through V2 is equal to V2, and in brackets you got 1 over R1 plus 1 over R2 all the way up to any number of parallel resistors that you have. And then taking V2 on the other side, you've got the current divided by the voltage. Now, if you look at the Ohm's law triangle, we have I divided by the voltage. So this is basically telling you that this is equal to 1 over the total resistance of the circuit or the equivalent resistance of the circuit. So we can rewrite I over V2 as 1 over RT, and that is equal to 1 over R1 plus 1 over R2 up to whatever number of parallel resistors you have in this circuit. So you can see we have now come to the equation for parallel resistors, which is basically shown over here. So there you have it, the proofs for series and parallel resistor combinations. Obviously it's quite useful to know where these come from. If you found this video helpful, don't forget to like and subscribe for more electronics videos like this. And if you have any questions on this topic or any other topic, just leave a comment in the comment section below. Thanks for watching.